Hello, everyone. Today, we're bringing you a blockbuster piece of news that's shaking the technology industry to its core. Reports have just come in that NVIDIA has effectively acquired the AI chip startup Groq for $20 billion, roughly 3 trillion yen in Japanese currency.
It's truly surprising. Announced on Christmas Eve 2025, right as the world was in holiday mode, this deal represents the largest transaction in NVIDIA's history. However, Rika, this isn't what you'd call a straightforward acquisition. It's a very unusual type of agreement.
Wait, they paid 3 trillion yen and it's not a normal acquisition? What does that mean?
To be precise, NVIDIA has entered into a non-exclusive licensing agreement for inference technology and is bringing Groq's core engineering team, including CEO Jonathan Ross, into NVIDIA. Groq as a company will continue to exist independently, but NVIDIA has effectively secured its key intellectual property and top talent.
For NVIDIA to want Groq that badly, what kind of technology does Groq actually have?
The key figure is Groq's founder and CEO, Jonathan Ross. During his time at Google, he invented the TPU, the Tensor Processing Unit, which has become a de facto standard for AI processing. He's a brilliant engineer.
So he built the very heart of Google's AI systems.
Exactly. He left Google in 2017 and designed the LPU, the Language Processing Unit, a chip specialized for inference that eliminates the inefficiencies inherent in NVIDIA's general-purpose GPUs.
GPUs versus LPUs. What's the real difference?
NVIDIA's GPUs are general-purpose computing devices. They can handle AI, graphics processing, scientific computation, you name it. That versatility is their strength. Groq's LPU, on the other hand, is designed exclusively for inference, the phase where an AI model produces answers. This specialization is the source of its astonishing speed.
Talamora, last time you explained that Groq excels at large language models. But AI isn't just about language. Image processing is also critical. In areas like image generation and medical imaging, is Groq actually faster than NVIDIA's GPUs?
Great question, Rika. In fact, Groq's LPU has the potential to outperform GPUs not only in language tasks, but also in image classification and diffusion-based image generation. Some benchmarks show that it can generate a 1024-pixel image in under 1 second.
Under 1 second for 1024 pixels? That's incredible. What's different compared to GPUs?
The major difference is overcoming the memory wall in image processing. NVIDIA GPUs often hit a bottleneck when reading and writing data to VRAM, or HBM. Groq, by contrast, integrates ultra-high-speed SRAM directly on the chip, which means there's almost no data movement overhead even for large vision models.
That makes sense. Image data is heavy, so faster memory access is a decisive advantage.
Exactly. On top of that, diffusion-based image generation is inherently sequential. It repeatedly performs step-by-step calculations. GPUs excel at parallel processing, but for these sequential workloads, Groq's design, where the compiler fully controls execution order through static scheduling, eliminates idle time and achieves far greater efficiency.
Are there benefits beyond just speed when it comes to image processing?
Yes, real-time performance and predictability. Think of medical imaging or autonomous driving, where even a momentary delay is unacceptable. GPU latency can fluctuate depending on load, but Groq uses a deterministic architecture, meaning it always delivers results with ultra-low latency. This makes real-time medical diagnostic support far more reliable.
So it's not just fast, but consistently fast. That sounds ideal for automated image generation workflows, too.
Absolutely. Systems are already being built that integrate Groq with image generation engines like Stability AI to rapidly generate, process, and upscale images. Training still remains NVIDIA's stronghold, but in inference, where you want answers now, Groq's advantage will only become more pronounced.
Narration. NVIDIA's GPUs are like 1,000 artisans painting simultaneously on a massive canvas, powerful but uneven when they need to fetch paint. Groq's LPU, on the contrary, is like an ultra-fast, fully automated printing machine. Since the ink, or data, is always on hand, it produces precise images instantly and without hesitation. But Kawamura, NVIDIA is already one of the most valuable companies in the world. Why didn't they just build this themselves instead of acquiring Groq?
Because the center of gravity in the AI business is shifting from training to inference. Training is a one-time capital expenditure, CapEx, but inference generates ongoing operational costs, OpEx, every time users interact with AI. In the long run, inference is where the real money is.
So for NVIDIA, which dominates training, the emergence of a competitor like Groq with overwhelming inference speed was a threat.
Exactly. Just as Google used TPUs to break its dependence on NVIDIA, other hyperscalers could have used Groq's technology to build their own chips, shrinking NVIDIA's market share. This deal is both defensive, eliminating a future rival, and offensive, securing the world's best inference environment.
Then why structure this as a licensing deal instead of a full acquisition?
To avoid antitrust issues, Meta, Microsoft, and Google have recently used similar approaches to absorb top startup talent. By keeping Groq formally independent, NVIDIA makes regulatory approval far easier.
Looking ahead, how will this change our lives and AI development?
The key is integration with NVIDIA's software platform, CUDA. Developers will be able to use familiar CUDA tools while the underlying hardware, GPU or LPU, is automatically selected to deliver optimal performance without them needing to care.
Training on powerful GPUs, inference on ultra-fast LPUs. With NVIDIA controlling both, AI progress could accelerate even further.
Exactly. 3 trillion yen is an enormous sum, but it's a nuclear-class strategic move by NVIDIA to secure AI dominance for the next decade.
Understanding the technology behind it really makes the significance of this news sink in. Thank you, Kawamura, for the detailed explanation.
My pleasure. The AI semiconductor war is just getting started.
On this channel, we explain AI and its impact on investing. Please subscribe.